SOFTECAsia 2024, the next generation, commenced with the first keynote entitled Loss Test Automation Fundamentals. This keynote speaker, ladies and gentlemen, have clocked over 42 years of management experience, has led numerous teams of software development professionals to achieve successful, high-quality product deliveries. A highly respected figure in the software engineering community and author of the popular child books on software testing, I Am a Bug. He served as an adjunct professor of software engineering at McGill University and fulfills the role of principal consultant at amibug.com Incorporated. Ladies and gentlemen, please welcome our first speaker, Mr. Rob Sabarin, amibug.com Canada.
Thank you. Sorry, I have to shake your hand there. Thank you. The first challenge. All right, so testing technology here. I have a clicker. Does it click? Yes, it works. Okay. Water. All right. Time. I don't see a clock. Do we have time? No. So I try to work to a fixed deadline when I'm working on a project. You ever work on a project with a fixed deadline? You know that you can test forever and forever and forever and never stop. This is exactly how I am when I'm doing a conference talk. I can talk forever and forever and forever and never stop. So I'd love to get information about the time, if someone can figure out a way to do that, how much time to go. So I have been involved in software engineering for a long time, and for the last couple of years, I've been involved with a group called WESTF, W-E-S-T-F, the Workshop on the Evolution of Software Testing Fundamentals. And we've looked deep and hard at what are things that are really skills related to software testing. What is a software testing skill? And what does it mean to be able to apply a skill to get a job done? This is a little bit inspired by what I consider is a terrible trend in our industry to focus skills as a list of tools. I'm sure some of you have a resume. I don't know if you do. I'm not encouraging you to make a resume, but let's say you have a resume. In there, somewhere, you have a section called skills. Next to that, you probably have words like Java and Selenium and other types of tools. Those are names of lists of tools. Those are not skills. The skill is how you might apply the tool to solve a problem that adds value to the business, but the name of the tool is just a filter for human resources to put your resume on one pile instead of another pile. It's not a skill. So what are the skills? Where did they go? So we've been looking at examples from past projects, from successes, from failures, from things that work, from things that don't work, to try to find, are there actually fundamental skills in there that we should be encouraging testers, existing practitioners, and new to the field testers to hone up and develop those skills so that they can apply these skills as technologies evolve and emerge around you. The one certainty you have in our field, absolute certainty, is it's going to change. Now people say, Rob, do you know how to program? And I'll say, sure, I've programmed in a lot of different languages. And then they say, which languages? I start listing off about 10 or 12 languages that I've written commercial programs on. Someone asked me to enumerate it. I was up to 35 languages. And what is that skill that I have in there? Not one of those languages is the skill. It's the ability to learn a new programming language. That's the skill. To adapt to a new programming language, that's a skill. Not the specific language. And by the way, those of you who are using conversational AI technologies today, they're fantastic at managing the syntax and nuance of a specific language. You don't have to worry too much about remembering all the syntax of a language. Who cares? You can look that up. It's how do you solve a problem with a language? That's the skill. And what is the algorithm and method? So WESTF got together and we started researching and digging down and looking at old testing stuff. And the amazing thing is that a lot of the fundamentals we started finding came from testing that predates modern digital computing. People have been testing for a long, long time. Testing as part of product development predates digital computing, not by 2 weeks or months, but by almost 2 centuries. And this is not just loose, nuanceical stuff. It's beautiful, beautiful historical testing that's been done to basically change the world. And what's fantastic about this research is not just the fact that you start identifying what are the key skills, but you identify the beauty of our field. The beauty of testing is that we can make a difference, we can make a change, we can make the world a better place. And it's happened because of great testing over hundreds of years. And so we're going to look today at a few examples of this. I'm going to start somewhere in the 1790s. Look at testing projects, look at testing skills. I'll migrate to the early 1800s, get to the late 1800s, jump into Asia a bit at that point in time, because there's some cool testing that was done in Asia at that time. And then I'm going to jump into the early 1900s, and one of the most influential testing conferences in the history of mankind took place in 1903. A testing conference, 1903, in St. Louis in the United States of America. Fantastic conference, all about testing. And I'm going to end with telecommunications testing done around the end of World War II. All of this predates modern digital computing, and all of it helps me to identify really what are the fundamental skills. What are the real things that stick? What are the things that really, really matter? Thank you for the introduction, by the way. I just want to say one thing, that and I'm very honored to be invited here. Thank you. I love visiting KL and Malaysia and the people here, and especially the food. I'm particularly fond of the catfish, if anyone wants to talk to me about food. I love the Malaysian catfish style. This is the anniversary, the 25th anniversary of I'm a Bug, my children's book about software testing that I wrote, the 25th anniversary, and we came up with a new edition of it this year that's available at a very ridiculously low price, so I want everybody to be able to get it. There is no profit being made, and if we ever do make any profit, we're going to donate it to charity, but it's to get people to look at testing from a very fundamental perspective. What is the basics here? What really matters? So, because of the nature of this talk, I'm going to talk about some things that are history. When I'm talking about history, I'll try to stand on this side of the stage, and I'll pretend that I'm a narrator on the History Channel on the TV. You know the History Channel? Anyone familiar with it? So, History Channel, history stuff here. Sometimes I'm going to be talking about software engineering lessons. I'll be on this side of the stage, and I'll be Rob, the professor, talking about software engineering lessons. And sometimes I'm going to be telling anecdotes and stories, and I'll try to stay in the middle for the anecdotes and stories. So, history, software engineering, anecdotes. If I get to the wrong place, you're allowed to correct me. Tell me, Rob, move over there. You're talking about the wrong thing. So, as I go, I also will move this way a little bit because of the clicker. Anyone ever seen a jacquard loom? Jacquard loom. Some of you have seen a jacquard loom? Never. Have you ever seen a silk shawl? A Malaysian silk shawl. I bought one yesterday in preparation for this talk. I went to go to the bottom, level C at the Petronas Tower. There's a store that specializes in Malaysian shawls, and you buy it, and it's made of silk. And it's woven in a beautiful, beautiful pattern. It's some of the most beautiful silk you'll find in the whole world. This is not cheap, by the way. It's beautiful stuff. I like to bring it. My wife told me I cannot come back to Canada unless I bring a silk thing, so I didn't really buy it for the presentation. But when I bought it, I looked at that and I said, that is made with a complicated device. It is made with an automated loom. The loom that makes it picks the right thread in the right place, to put the right pattern on the right time, and is able to do it with quality and succession. So early looms were made in France by a guy called Jacquard. Jacquard made looms in the late 1700s. He started doing this in the 1790s. And by 1804-ish, he basically came up with what was called a programmable loom. So the loom had a program, and the program on the loom was created with punched cards. Just like you would have used in computing up until the late 1970s, punched cards were used to program Jacquard looms. The Jacquard loom looked like this. So the history here, so it's supposed to be on this side. So the Jacquard loom looked like this. It had a big deck of cards. You see at the top that big deck of cards. I have in my office in Montreal an actual Jacquard card there. And basically, as you go by row, you change to the next card, and you repeat the pattern over and over again, and it actually has looping and ways to skip things. It's actually a program language, and I was honored, anecdote here, there's a town in England called Macclesfield, near Manchester. Anybody never heard of Macclesfield? There's a famous tester who lives in Macclesfield. Her name is Dorothy Graham. Anyone familiar with Dorothy Graham? Dot? So all the speakers know Dot. No one else knows. Anyhow, Dorothy invited me over there. She lives next to a museum in Macclesfield which has 26 operational Jacquard looms. And I was invited to go to this museum. And when I went there, there was a whole bunch of little kids terrorizing the museum, so I couldn't see anything. And so I decided to come back later. And on a separate trip, I had the whole museum reserved to myself. And I spent one day, just me, Dorothy Graham, in a Jacquard loom museum. And I actually got to program Jacquard looms and look deeply at how they actually programmed them. It was amazing. When you're programming a loom, you get a special little keyboard. And the keyboard, I'm going to put this down for a second here. So the keyboard has places for your fingers and your thumbs. So there's a bar in the middle for your thumbs, and then your fingers go down on the holes that you want to punch. So you put down the fingers for the right holes, then you put down the thumbs to punch them, go to the next one, punch, go to the next one, punch, go to the next one, punch. 4 fingers on this side, 4 fingers on that side. There was an 8-bit fundamental data structure in the Jacquard loom by design because of the nature of the punching with your hands. So everyone wonders, why do we have 8-bit bytes on computers today? The programming of the Jacquard loom was an 8-bit system, and you have to program it to start seeing it. And you can see what can go wrong too. You get the wrong bits and the wrong pattern, and everything can be screwed up. So there's lots of things that can go wrong. And there was very complicated patterns that they're trying to make. So that story, I got to touch it, I got to play with it. Now, getting back to the history, Jacquard basically could do repeatable patterns, all sorts of things. It's real programs, right? Programs on a loom to make cloth. And you see that picture there on the left? That's actually made from a Jacquard loom. It's a picture of Jacquard made with a Jacquard loom, programmed 8 bits at a time for all the pixels in that image. It's amazing. It's like a JPEG file from 1804. It blows my mind how long ago this was done. And Jacquard had all sorts of interesting problem spaces to deal with, and there were risks in a loom. You had physical things, right? Mechanical things. Things could break. You could have hardware failure, the punching being wrong, something we call a dangling chad. The term dangling chad, anyone old enough to know what a dangling chad is? Again, all the speakers will say, yes, I know what it is. There was an American election which was decided by counting ballots which had dangling chads in the early 2000s, I believe it was. And dangling chads is a problem. When you punch the hole, it doesn't punch all the way through, it dangles. That's a dangling chad. It's like a programming bug, but it's not the fault of the programmer, it's the fault of the card. And there's also possibly incorrect input on these systems. So what did they do? Fundamental skill, fundamental thing. This is now, I'm going to jump on software engineering skill, because they realized we need regression testing. We need to regress the loom. We need to regress it. We need to make sure that if it worked last time, it works now. If it worked before, it works later. It's got to say that we haven't changed something, we haven't broken something, we haven't screwed something up. So they created beautiful, beautiful programs to do regression testing. And you're going to see now, this is a lost fundamental. Because right now, so many people are focusing their test automation on basically how do you sort of program the thing. And they create today, for example, like self-healing automation, and are using AI to come up with scripts and all sorts of cool things. But how do you assess correctness? The focus is how do you control the application, how do you set it into the right state, but how do you assess correctness? Jacquard came up with a model for solving the regression problem by using repeatable test patterns. And the repeatable test pattern is actually, in this case, this is an example one. This is like a cloth which has got a checkerboard pattern on it. And what you'll do is you take your Jacquard loom, you run the test program, it's an automated script, through the loom, build the pattern, and then compare the pattern you generate with a master pattern to assess to make sure that the loom is correct. And this is basically, I love that because it's repeatable, automated regression testing with complex methods to assess correctness dating from basically 1804. Way before anyone thought of digital computers. And I like that. I like that, saying, okay, when I'm doing automation, should I go to the history side or the anecdote side or the middle? I don't know. Let's stay in the software engineering side. When I'm doing automation, I don't just by starting to design how do you control the device. I want to see what is my strategy to assess correctness. And I want to design algorithms, come up with mechanisms, be very clever, figure out what it means to see did this work or not. It's not just a bunch of trivial assertion, pass or fail things. It's a richer, more complex thing. It involves designing something and coming out with strategies to assess correctness. And that's beautiful, that test pattern. I saw it first at the British Museum in London, England. The Macclesfield Museum is still there. You can actually touch and program Jacquard looms, but there's very few left in the world that are still running today. Obviously, this is ancient technology, so it's a historical thing. Anybody involved in software testing would benefit just by looking at that and figure out how would I test this, and then how did they test this? And the answer is they did. And the Jacquard loom changed the world. The Jacquard loom made it possible for me to go and buy a scarf for my wife in the Petros Tower yesterday. It made it possible. Jacquard, they still call them Jacquards. People who still make automated looms call them Jacquards. That story okay? Too boring? Not exciting, but what does he care about? Cloth, buying cloth. It doesn't matter. Well, maybe it doesn't matter. Okay, let's talk about social networks. How many people here have social media and social networks? Come on, raise your hand if you have an internet. Don't even, come on. Are you with me? Engage. There we go. So I actually don't really do much social media. I'm afraid of social media. But I'm really afraid. I'm paranoid about it. I'm worried my kids are going to see what I'm doing or something like that. I don't know what's going to happen. I'm afraid of social media. But there was a period in history when this whole idea started up, and it was called the Victorian Internet. The Victorian Internet. And there was actual social media, messaging, all that type of stuff in the mid-1800s on the telegraph system that they put up. There was actually social media going on back. That's how old it is. There's actually a book called that, called The Victorian Internet. And it goes back to telegraph systems. Now there's a gentleman called Samuel Morse. This is history, so it's this side. Samuel Morse is an American inventor. He did figure out how to code data. He came up with something called Morse code. He figured out a data coding mechanism. And he basically figured out how to do all sorts of telegraph systems. So telegraphy was like a key. You hit the key up and down, it sends bits down a line, right? This is the system. Now, they didn't have telegraphy. In fact, telegraph systems is considered to be one of the first true electrical engineering problems. So people didn't understand electrical engineering. Forget about computers. They didn't understand engineering. They had to invent a lot of concepts for doing this. And to build this system and to prove that it worked, they made a pilot test. So this is a simulation environment, 30 miles from Washington, D.C. to Baltimore, Maryland in the States, 30 miles. And they put on that network thousands of messages going back and forth, including real messages between people. People didn't even know what to put in these messages. They didn't know what to say. But it was live conditions, live data really happened in the outside world, and they basically studied the behavior of these systems. They studied the behavior of systems, and Samuel Morse wrote a test report to share his findings. And that test report was probably the most influential test report ever written in the history of testing in general. Because that test report convinced the American government, this is before the Civil War, right, in the 1840s, to invest in a transcontinental telegraph system as a result of testing, as a result of a test report written by Samuel Morse. This is phenomenally influential, and if you read the report, you're saying, why was this so influential? Like, how do you talk about technology to a bunch of politicians? And you get in there, and he's talking about risks. He's talking about real fundamental stuff. But it wasn't just risks, it was the benefit to society by sharing real examples of what real people really did with the system. So if there's a problem, it's not because some light was red instead of green in a dashboard. It's because this user can't do this thing in this system. Or this event happened that was positive or negative. And there was all sorts of stuff about what people could do that influenced the success of this project. And it was beautiful to see this report. But on automation front, to do that project, they needed to get tools to help support the testing of it. They did not have these tools. So a gentleman called Wheatstone, his name was Charles Wheatstone, worked with Samuel Morse to come up with tools that could support the testing. So there's a testing objective, a testing goal, a testing environment, but we needed tools to support the testing. And one of the most famous tools that was invented is called the Wheatstone Bridge. That's a Wheatstone Bridge. Even when I went to university in 1979, I learned how to use a Wheatstone Bridge, which was invented to support testing of the telegraph system in the 1840s. It's a tool. It's a balancing tool. It helps you find bugs. It helps you do dynamic analysis. How's the system working in real time while it's running? It helps you check things like basically isolating and detecting faults. You ever heard of a memory leak? They were looking for current leaks in telegraph systems with Wheatstone bridges. Amazing technology invented to test telegraphs. Now, this is a tool that supports the testing, and it's a fundamental now. The tool supports the testing. It's not the testing that supports the tool. It's the tool that supports the testing. Get tools that support your work. Find tools. Go to the vendors and have them create tools that help you do this. But don't become the slave to the tool. Your job is a tester, not a machine tool operator. It's a different thing. Also, Wheatstone invented an automated telegraph test automation system where if you look at the top of this, there's a perforated slip. That was a long slip of paper with holes punched into it that would be read by this machine, mechanical machine, that created transactions on the telegraph line, just like capture, playback, test automation tools still being used widely today. And it's incredible. Now, if you think about, could you make a self-healing tool like this? What's a self-healing tool that you fix the hole with paper tape or something like that, or glue, or what do you do? The answer is no, you want it to fail. I want to find a weakness. I want something to break. The whole point is to find the problem, not to sort of eliminate failures and stuff. Beautiful, beautiful devices, beautiful technologies. Again, ancient history, tools to support testing. And there's nothing new about this. It's beautiful stuff. There's also, and I'm referring now to a little bit of history. In India, they got so big on telegraphy that they set up books on how to test telegraph systems. And there is a book I have, 245 pages, about how to test telegraph systems in India from I believe it's 1870 when I got the reference on this book. Testing telegraph lines, technical arrangement offices, under the order of the Director General of Telegraphs in India. Volume 1, there's multiple volumes. It's 248 pages, and it tells you how to use Wheatstone bridges, tools like what they called galvanometers at the time, and all sorts of other stuff. It focuses on showing you the fundamentals, and almost half of this book is math. It's showing you how to use applied mathematics to solve the problem. How many of you guys use applied mathematics when doing testing? Testing is almost always, when I'm designing tests, applied discrete mathematics. Can you bring your problem down to something that you can grab from the world of math? And discrete math is the one in software testing that shows up now a lot these days. A quote from that book: "Before the tester proceeds with testing, he must satisfy himself that his instrument is in perfect order." This is done as follows. This is actually in the book. What is this saying? It's saying, don't trust the tool just because the tool claims to do this or the vendor claims this or that. Challenge the tool. You should challenge the tool. Before you start using it, make sure it's working, make sure it's calibrated, make sure it's going to give you information with some truthfulness and some veracity. Something you can trust, something you can use, something that we can make the world a little bit of a better place as a result of it. And I love this. This is fundamental. This is so key. How do you make sure you can trust your tool? I don't care what you're using for automation. How can you trust it? And don't blindly start saying, let's import libraries and do this stuff. How do you trust libraries? Someone's going to update a library and ruin your life, and you don't know it. So should you create what we used to call a smoke test? To say, okay, let's run this smoke test with this tool to make sure that we can trust the tool with further work. And if it doesn't pass the smoke test, we're not going to trust the tool. We'll use the old tool or the old version of the tool or something like that. So I love this notion from the 1870s telling you to don't trust tools. And I don't want to criticize vendors if there's any in the audience. I love tools. I'm a tool fanatic. Again, I want to trust tools, so I want to figure out a way to sort of smoke them out. So we went from cloth manufacturing. We talked about telegraph systems, which changed the world. It made us all be able to communicate, social network, all that stuff. But then we had to move, right? People moved. And there was this locomotive testing. I guess mobility, would that be it? Mobile testing, maybe? You associate mobile testing with little devices that you carry around in your pocket. You don't have a mobile phone? Not in Malaysia yet? Really cool, no? I don't have one with me because I left it in my bag there, but I usually have a phone these days, but I don't trust mobile phones. I want to get my old flip phone from Motorola. And I dropped it in a coffee one time. I think I was in Malaysia. I dropped it in a coffee. It was a terrible experience. Anyhow, mobile means moving. And people used to move a lot, but in 1904, they had a conference about locomotive testing in St. Louis, Missouri in 1904. 1904 was the 100th anniversary of the Lewis and Clark expedition, which is a famous exploratory testing paradigm from the 1800s also. But this is basically a conference all about testing. The proceedings are available. You can buy them on Amazon or download PDFs of them free of charge. It's fantastic to look at a conference all about testing locomotives. Huge, not just little things, huge things, and details, beautiful details. They have major exhibits, was a World Fair. They had live testing going on. You could see live testing and tons of automated testing of steam-powered locomotives. You might ask, how do you automatically test a steam-powered locomotive? Well, part of it, I guess, is modeling. So the steam-powered locomotive industry had a lot of modeling going on, and their models were really cool. And I love this. I think, hey, wait a sec. When I'm doing test automation, isn't that the fundamental thing? That I have some sort of model of how the computers work, how the system works, how the resource works, and the model is something I can help saying, hey, is the behavior of the system consistent or inconsistent with my model? 1904, models of the usage of railway systems. Models of freight yards, models of tunnels, models of just models. But not just little baby models, scale models, big physical things that you can touch and look at. It's an amazing world. So let's see, model usage. Simulating the environment. Take a look at this picture. You see the wheels of a train standing on other wheels. They could simulate a train in motion while it's standing still by having it sitting on top of rotating wheels. They would get trains running over 100 miles per hour on spot in St. Louis at this conference. So can you imagine you go to a conference and you see this train running, but it's not moving because they're doing an environment simulation, simulating the environment of it. And while they're simulating the environment, so you simulate the conditions of the application, but while that's going on, you do dynamic analysis of the system. And while you're doing test automation, so many people today, they learn these tools, but they forget, how does the system use resources? How does the system use processing, memory, network, bandwidth, any consumable resource? How is it going on? And during this testing, what they would do is they would have the train running, and they would have dynamic monitors all over the place with dials everywhere, and they would be monitoring and taking track of values of all of these gauges and things while the train was moving. So they were doing what is really dynamic analysis. They were looking at non-functional attributes. So much automation is focused on hitting keys and simulating transactions, and people forget totally about attributes of the system, characteristics like ilities, usability, reliability, maintainability, availability, scalability. All these ilities are missing today. You're focused on functionality. Well, functionality is important, but quality factors, that's the game changer. Does it scale? Will it last a long time? Will the train be able to go for several hours uninterrupted? And they did a lot of comparative analysis too. They have charts and curves, the book's full of these things. Beautiful, beautiful study. This is horsepower at different rotational speeds for different types of trains. They were doing data analysis, curve fitting, data analytics. Before anyone invented AI, they had data analytics in 1904, and it was good. And they didn't have spreadsheets or databases. They didn't know what a digital computer was, but they knew what data was. And they knew how to compare and contrast and come out with really beautiful things. They also figured out ways to visualize the results. This is a visualization of a non-functional test result from the proceedings in 1904. If you look at that image, you can actually see the rotational complexity of the wheels in a very clear picture. Edward Tufte, who wrote the book Visualization of Quantified Data, would trip seeing this picture. It's beautiful. They figured out ways to visualize the data so people can make meaningful conclusions from it. It's not just a pile of data. It's coming up with a way to visualize it so people can get meaningful conclusions from it. Also, in 1904, there was a lot of emphasis spent on failures. And there's sections of the documentation of the conference that said it's very important when you're testing railways and you have failures that you look deeply at how it failed and understand failures. And this is what really bugs me, but so many people are focused on getting everything green, and you have things that are red. Well, why is it red? Why does it keep coming up red? And understanding that, understanding the nature and the root cause, and maybe use that to sort of try to change things, to make things maybe a little better, a little worse, a little different. And this is beautiful. They study failures. And this, of course, in railways, failures could be devastating, right? Physically devastating. And I guess in software systems, it could be devastating as well. How am I doing on time, just to give me a hint? 30 minutes to go or 30 minutes left? To go. Oh, that's lots of time. Okay, so we'll talk about, I went fishing this last couple of days in the South China Sea. Does anyone go fishing in the South China Sea? I was trying to catch sailfish. I did not catch one. The biggest fish I caught was about that big. So I claim it's a little teeny weeny fish, but I'm going to use image processing software to make it look like it's a big fish. My dad, during World War II, was in the Canadian Air Force. He was a mechanic. And I was brought up as a child by my dad and my mom in the 1960s. I had 2 brothers and 3 sisters, pretty large family from Montreal. And my dad would be telling us always stories of his career. And when he was talking about the Air Force, he was a mechanic, and he would always tell us about testing. So I'm hearing all these mechanic testing stories from my dad. And the beautiful thing about it was he was repairing aircraft that is going to be used in military conflicts in a time when it was very important. Aircrafts were very critical to the war effort. And Canada wasn't where the theater of the battle was, but a lot of the planes came from Canada. And what they did was they made everybody who was a mechanic involved with the repair of the plane or the creation of the plane flying the test flights. Think about the accountability. Imagine you had to fly the plane that you just fixed. Aren't you going to be just a little bit more careful when you fix it, right? So my dad was telling me those stories. And then after the war, the Canadian government had a plan where they let paid soldiers to go to school to finish their education. So my dad went to the Radio College of Canada, became a radio technician in 1946 about, and he got a job working for Northern, at the time it was Northern Electric, it became Northern Telecom, now it's nothing, but it was a big, big telco. And he got a job in the department that was called Test Set Maintenance. Test Set Maintenance. That was his job after the war at Northern Electric. And my dad did programmable test automation of telephone systems from 1946 to about 1950 using tape-o-matic test sets from Western Electric. And it was all programmable automated testing, again, predating digital computing by years and years and years, to test complex telephone systems and electromechanical relay-based telephone switching systems. So I'm a kid, and the stories my dad is telling me when I'm a little boy are all about testing stories. So I'm brought up with this, like, in my DNA now. I got all this testing, like, love testing. My dad the tester was always the hero of the project. The tester was the one who people went to, the engineers, they wouldn't move anywhere unless they had the tester trusting their work and saying it's okay to go to the next. It was just amazing. It was sort of apolitical. And my dad actually, from that, was hired into the engineering department from the test set department, and he became, eventually, when he retired from that company, he was the manager of overseas operations of Northern Telecom. So that's, from a tester, there was a career path of some substance. And it started by being a kid from school who, how do you test a telephone system? You write a program. And that was test automation. And it's beautiful stuff. Now, I looked into these systems because I love the story of automatic telecom testing. And I studied them. And it's basically from 1930 till 1947. That's the heyday of automated testing for telecom systems. And this is where they introduced, the first time I saw it, was the term manual testing versus automated testing. That's, for me, that's my first reference on that. And the early test tools they had were manual tools. And you'd have a person, a tester, would have to control thousands of little switches, run a trial, do thousands of switches. It was a very tedious and laborious thing, and easy to accidentally make a mistake. So they wanted to try to eliminate human error. And so they created what was called the Cardomatic test set. This is from 1942. The patents for this date from the 1930s. All the patents for these tools are available online, so you can actually see the patent documents describing these tools. It's amazing stuff. But the Cardomatic was programmed with punch cards. This was the generation before my dad started. And then they came up with the Tape-O-Matic. And I found an ad for the Tape-O-Matic. So this is marketing telecom test automation tools. Marketing the tools. They're making claims about what the tool can do. And what's really cool about it is they talk about, how long is a test by how many feet in length, linear length, how many feet is this test? And they said they have 1,200 different tapes varying in length from 1 to 30 feet. They're used for testing various assemblies. Formerly an operator in testing an average size assembly had to make 41 individual connections. So with the Tape-O-Matic, 1 multiple plug connection does the job, and 28 preliminary tests, 81 lamps, observations, 71 key operations. So you're simulating 71 inputs and you have 81 observable outputs, all under program control. This is the marketing literature from, it's a claim. Do you trust the claim of the marketing? I don't know, but it's marketing of test automation tools from a long time ago. That's what a Tape-O-Matic looked like. It was basically paper tape punch machine. And it basically, I guess, sort of got me excited about engineering and testing in general. I mean, that's why I'm here, that Tape-O-Matic system. And it was indeed trying to simulate telecommunications traffic in a controlled environment so that you could find the bugs and problems in the system before you went live. And these systems had to be incredibly resilient and reliable. Telecom systems with mechanical switches and electromagnetic relays, mechanical switches, vacuum tubes. There's a lot of room for failure in those systems. Today's telecom system is all electronics. You don't see any of the physical stuff, but back then, when you dialed a number on the phone, you really, the things physically moved. So you can imagine running the test automation and all of the switches are all moving and everything's going physically at the same time. It's a sort of a beautiful thing. But their simulation led them to build confidence. And that's a sort of thing to keep in mind. Why are we doing our test automation? Why are we doing it? And I like to believe that testing should be purposeful. Testing should be purposeful. And I want to give you, this is Rob Subb's quote on the subject. On time, on quality, and on budget are meaningless concepts unless you're on purpose. What is your purpose? When you're trying to automate a test, what are you trying to learn about? And why are you trying to learn it? And how will that information be used to help advance the project and the stakeholders? How does it give you insights into quality that matter to your team? It's not just the question of saying, I know how to program this tool to do a few things. It's a question of how do I take my cognition and turn it into value for the business? Tie your work to the purpose. Do purposeful work. And you find that in terms of the tape-o-matic, the purpose was to build confidence that the system would be reliable enough for its operational thing. So you wanted to simulate operational readiness of a system. Sometimes we have other goals. In software engineering, it is not uncommon that people are afraid that we might inject a bug in a system. You've heard of that, right? People have put bugs in software. They don't do it on purpose. They do it by accident. Watts Humphrey from Carnegie Mellon Software Engineering Institute, Carnegie Mellon Software Engineering Institute, Watts Humphrey, to quote him, he studied thousands of projects. And his quote is that for every 10 lines of code added or changed by even the best developer, a defect is injected. So a programmer fixes a bug and changes 30 lines of code to fix a bug. The chances are that you've injected 3 bugs you don't know to replace the 1 bug you know. Is this good or bad? I don't want to judge. I just want to say there's sometimes a purpose for automation which helps me build regression confidence. So the regression confidence, in that case, the regression confidence is that the behavior of this series of tests that I ran yesterday is consistent with the results today after I made the change. So if one of the results is different, I've learned something. Either it should be different or we accidentally injected a bug. So that's a purpose. Now, that's regression. That sounds like a noble purpose. That's a reasonable purpose. That's a powerful purpose. Thank you for that purpose. But that's not the only purpose. That's one purpose. There's a lot of other purposes. So be careful. Don't get caught up in the universe that everything has to be a regression test. Test automation helps support your work in testing and development of software. It does not always have to be a regression test. All tests don't have to be regression tests. You can design a test for a lot of different purposes. Now, in digging through all these different projects and all these different things, it's become key to me that people involved in test automation really have to not just learn about some technology fundamentals, but to identify and master some fundamentals. And I mean master. If you're looking at your job, career, advancing the future, look at the future of testing. The future of testing is to apply fundamentals to new problems that no one can imagine the problem, but we can imagine the fundamentals. If you master those fundamentals, you'll be able to solve all sorts of problems. If you don't know the fundamentals, you master a silly tool, that tool's going to be out of in 5 years, who's going to care? The tools change, the programming languages change, the environments change. Yes, it's nice to get a certificate in AWS, but that's only now, that's today. Who knows in 8 years if that's going to matter? But there's something fundamental in there that is always going to be the same. And that includes, in my little list here, Boolean algebra. Boolean algebra is something that can be taught to people as young as third grade in elementary school. It is not complicated, but it is absolutely fundamental. Recently, at a customer of mine, I found someone writing test automation scripts, following like a template for test automation, and they could have dramatically simplified the problem by using just basic Boolean algebra. And I showed them how to do it, and they said, oh, I never thought of doing that. So Boolean algebra is the fundamental basis of digital logic. Learn it, master it. It's not a complicated thing. And or not, those are the fundamental things. True, false. I'm not saying that you have to be able to do everything with Boolean algebra, but know it and apply it. Then there's Aristotelian logic. This is very important for making assessments of correctness by inference. So if it's true for this and it's true for that, what does it mean about something else? So this is like logical syllogism, stuff like that. Set theory, especially in testing, sampling and set theory, and maybe statistics are related here, but we cannot test everything. Edgar Dijkstra made it very clear to us in his work in the 1960s that testing can show the presence of bugs, but testing cannot show the absence of bugs. No matter how much testing you do, you can only show if a bug is there. You can never show by testing that something is bug-free. It is impossible. We've known that since the 1960s. It is impossible. So we are always trying to figure out when we design our tests, no matter how automated it is, what subset do we want to exercise of the vast number of possible tests? What small subset are we going to exercise so we can learn the most of value to the purpose of the project? This is basic set theory, to be able to identify meaningful subsets. Those of you who have studied foundations level ISTQB stuff would maybe know that as equivalence partitioning. Well, do it. Master it. Live it, breathe it, see it. Make it part of everything you do. It's part of your automation. It's the whole purpose of testing, is find that subset. Rhetoric, I think the fundamental is to be able to make persuasive arguments. Who cares if you find a red-green flag? I want to write a persuasive argument to convince you to act on it. Think of Morris's test report to Congress. Influence change. Make your results meaningful to the business. This is a rhetoric, argumentation. It's a fundamental skill. I think it's also fundamental to realize that when we're doing test automation, we're using computers to help us solve a problem, or using tools to help us solve a problem. I think the key thing is here, how do you solve a problem, or how do you solve a problem with a computer? And I learned to name this algorithm design. Does anyone use the term algorithm design? Algorithm in general, you hear the word algorithm. Certainly, if there's programmers in the room and you don't know the word algorithm, I don't know what your job is, but an algorithm is basically like the steps you use to solve a problem. And there's some well-understood algorithms, especially for searching and sorting and organizing data and manipulating data, some well-organized algorithms. And then there's things like we have to design an algorithm. And a classic example I saw recently was I had a medical data system which was basically collecting data in a remote system that had to synchronize with the server, and we had to figure out how to basically test the synchronization was working. And we had to come up with some interesting algorithms so that we could learn that very quickly. We used what was called checksumming and some distributed programming, but it was algorithm design. That was the automation skill. So I think learning how to solve problems with computers, even if you don't have the programming skills, you can still figure out what is the algorithm and then work with the programmer with the programming skills to get the job done. It's not the coding that matters, it's the algorithm. It's how you're going to use the computer to solve the problem. In general, also, understanding how computers help involves things that are, I think the more common was simulation, right? Simulate the environment, being able to change the simulated environment. Today, that's becoming easier to do with the technologies like VMware type of technologies. But controlling and observing. So how can we see something, and how can we influence something? And I'd like to suggest and challenge you to figure out multiple ways to do that. I don't trust my eyes, so I always try to have 3 independent ways to observe things. And I like to have at least 2 different ways to control things, maybe 3. But it's I will even work with developers to put hooks in the code to facilitate my controlling the state of the application for the purpose of testing. People used to say that was a bad thing. Don't modify the application for testing. That was evil and bad. Well, today, if you don't do that, you're missing the boat. Work with the programmers, build testability into the product, make it easy to test. Take this silliness, like self-healing testing universe, and just eliminate the need to do that. Put a hook in the application so that you don't have to go through that UI layer to automate the transactions. When you're testing the UI, test the UI. Make sure the UI does what the UI has to do. But for transactions, you can go underneath the UI somehow, and almost always programmers can expose an API or some mechanism to do that, almost always. I think it's important to understand fundamental computing models. This is something that has been bothersome to me in my career. Many people have never heard of von Neumann. I'm not saying you should read the biography of von Neumann, but von Neumann came up with what is called a basic computing model. And he wrote this stuff in the 1940s. And in the 1950s, when people came up with the first modern digital computers, they used the von Neumann model. And to this day, the von Neumann model is dominating any computer device you have, embedded system you have, cell phone you have, satellite system you have. It's the basic von Neumann model. And the von Neumann model is trivial. Memory, processor, and input and output. Did you know that the memory that your program lives in is the same memory that your data lives in? And that your data can overwrite your program and your program can overwrite your data? And this is a huge risk. I run into testers all the time who have no clue what I'm talking about. And it's okay. Maybe it's a level of abstraction for me, but what is your model of the computer? What do you think is happening in here? And when you start understanding the computing model, then you can start looking at what you can do with it. Think of how complex and beautiful the programs people write today are. We can use that to create complex tests. Same thing as creating products. I think it's important to build skills in learning new languages and new technologies. I'm not 100% sure I've got the best methods, but I do have some methods that I try to teach my students on how to learn new scripting languages. I try not to get attached, especially emotionally attached, to scripting languages. I know there's some people in the audience who probably love their React.js universe. There's some emotional people I saw in the back that were talking about Python. It's just almost in tears. It was so sad to see them they loved their Python script. And then at McGill, where I work, it's a bunch of Java programmers. It's scary. They're walking down the street, and you can see behind them a trail of Java code following them. And there's people sometimes get emotionally attached to a technology stack, and I said, that's probably not a good idea. Learn how to learn ones, learn how to do things well enough, maybe take advantage of modern AI technologies to help you worry about some of the syntactical nuance, but it's important to be able to adapt to and learn new technologies. The computing model won't change, but the scripting language will. So have fun with that. I turn it into a fun activity for me. I'm always doing it. So lost fundamentals. In a nutshell, test purposefully. How fundamental can you get? Do it on purpose. Have a purpose. Make sure, and if someone is asking you, telling you, do this automation, find out why. Don't be sarcastic about it. Really, what do you want to learn from this automation? What is the purpose? And there's a big difference between seeing is it resilient and seeing if there's a regression bug. Big, big difference. Take a problem-solving approach. Always have some sort of strategy. How am I going to solve this problem? Look at multiple ways to assess correctness. Thank you very much, by the way. That's a very nice sign with the number on it. The number was 10. Did you ever see Sesame Street? No, it's an American TV show that focuses on numbers between 1 and 10. So, problem solving. Take a problem-solving approach. Use your knowledge and skills to solve problems. Make the testing challenge fun, not laborious, but solve a problem. And not just for you, for others, and forever and for always. Don't just do it today. Do it forever. Model, come up with computing models. Model the system behavior. Look at the railroad testing models, where they basically came up with models to test things like freight yards. It's fantastic. Learn how to control and observe systems, as we said. Provide while you're testing, active feedback and act on it, being able to tweak and adapt your testing as you go. Share your findings, advocate the work that you're doing. Always explore, learn, and adapt. Never give up, never surrender. Maybe know a few people who are passionate about the craft, like I'm fanatically passionate about testing. I love testing. I love hanging out with people who love testing. I want to help you try to turn it into a powerful, powerful attribute for your continued professional and business success. That's all I'm going to jam about now, but I'm happy to take any questions or things from the audience if we have a facilitator to help with that. How do we do that? There's this microphone, maybe? Sorry about that. Just
Hi, Robert. My name is Johnny. Wait, a bit too tall for this. Okay.
I don't hear very well.
Can you hear me now?
Yes.
All right. My name is Johnny, and my question is, because you mentioned the importance of soft skill and the fundamentals of skills for us testers, but then with AI, I think it's very easy to build reliability to it, to the point that sometimes we're too relying on AI to the point that we are losing our soft skills and our fundamentals. So how do we navigate with this new technology while also keeping the skills of us? And I think some problem and some some fear of us in technology world is that with AI, we're going to get replaced by it. So how do we navigate it? How do we not be replaced?
Well, first of all, thank you for the question. And I think if you take the word AI and look at, and just consider this a new technology. So today there's a new technology. And there has been my whole career, always, always, always new technologies. Some of them magical, some of them bizarre, some of them contorted, some of them threatening. I found people who locked in their career to a previous technology path and didn't focus on learning new technologies and evolving, eventually were the ones who were most threatened by new emerging technologies. To be specific about AI, so I have a lot of fun playing with it. I am working on some projects with it. I learn, especially from people like Tarek and others who are really grounded in the field about what are the practical limits, and I'm afraid of it. I don't like the fact that a lot of the AI stuff I see is distruthful. It lies, it makes up things you want to see. Especially in algorithm design, it gives you what looks like an algorithm but actually is wrong many times, and I've done a lot of research on this. So I don't like the fact that it makes things look good, and because it looks good, people trust it. It's not necessarily trustworthy. So right now, I'd be highly skeptical of it. I would use it as a sort of a way to come up with new ideas, but not to the work of testing, but do like gap analysis. Like, here's the testing ideas we have, here's the requirement we have. Can we come up with things that I'm not touching, or things that are risks and gaps and omissions? But I'm also working with Ben Simo, who spends his whole career addressing that question. And he said the best way to answer it is, I don't know. Please tell me when you figure it out. I'm not afraid, because I look at it as a new tool, which I think is going to make a lot of my job easier. I especially have fun with syntax of programming languages I'm not familiar with. And I've done great work with it, with databases, just to help me syntactically. I find SQL offensive, but I can program it. But with ChatGPT, I can come up with some scripts to help me. I still have to write my own code, but it helps me get around a lot of the silly syntactical stuff. So I do think right now it's at a state that's useful, but it'll probably get more useful. Keep in mind that AI systems also, you train them. And so if you have a closed training model, you might take your repository of scripts and train it to see these are the scripts we have, and then use that to make inference. That might be interesting, as opposed to taking the world in general. Because the world in general is full of all sorts of garbage and crap. And I hate to say it, but a lot of the AI I've seen, generative AI, just is full of mistakes. So I'm not afraid myself. I like learning new things, but I don't feel threatened by it. I think that vendors are claiming things that the tool is going to miraculously do something that it's not cognitive. It's just, it's certainly nice and useful for finding holes and things, but I'm not sure about the threat of it. In the short term, I would be as aware as I could to take seminars, learn things about it, but I really don't know what the future holds in that area. Right now, I'm playing with it, but I wouldn't put a lot of my effort into it, except for trying to identify gaps and holes in the things I'm testing. I made a specification for a device called the Wrap-O-Matic. It's a fictitious device to wrap chocolates. It's a complete formal SRS. Plus, I've got all the formal user stories for it, and I've got the state models and diagrams and decision tables. Fed all this in to one of these AI systems working with Ben Simon, and asked for test ideas coming out with. And it came up with a beautiful set of testing ideas, except that a lot of the test ideas were for features that weren't in the product. Like this was making up stuff. And I couldn't believe it. Like it was just turning my stomach, saying, how could the tool be doing that? Now, if I was naive, I might have thought that's a useful test, but I wasn't naive, I was aware of the product. But unfortunately, my level of trust dropped dramatically when I saw that. So it's, you have to be in control of the learning part, the learning part and the use of it part. And the general stuff, I don't think it's really ready yet. Maybe. What do you think?
For me, I think it's kind of impossible to completely change testers into AI. But then with new technologies, of course, people are going to jump into it at first, and then after a while realizes, oh, maybe this is like a wrong decision.
Well, yeah, I mean, and you're going to find something that it's going to help you do something, part of your job that you used to do that was tedious and laborious. For example, I still write articles. For me, I write an article, it's 3,000 words. And before I publish the article, I get it professionally copy edited. And I used to pay up to, for a 3,000 word article, about $75 US to get it copy edited. Usually I would send it to India to get copy edited. And I got it back, and it was just to clean up the grammar and, not to change the meaning, but to tighten the language. I haven't done that since I've been exposed to modern conversational AI, because the AI systems are just very good at copy editing text. So I'm saving myself $75 every article that I made on it, and I trust the copy editing. That's not creating things, that's taking the grammar I give it and just tidying it up, tightening it up, not changing the meaning. I think it's very good at that. So there's something you might find in your job or in your universe that maybe is going to be a place where it'll help you a lot with tasks that otherwise are laborious or costly. Yeah.
Thanks, Robert.
Right, thank you very much.
All right.
Okay, Robert?
We good?
All right, thank you very much, Mr. Robert Sorin.
Thank you.
Big round of applause, please.